So now we'll talk about the Robinson annulation. And this is a reaction that some classes might omit, but I would venture to say more than half the classes are probably still going to see this reaction. So it's a combination of two reactions already seen, so it's not going to be anything new from this chapter, but it is a Michael reaction followed by an intramolecular aldol reaction. So to be a Michael reaction, we've got to have a Michael donor and a Michael acceptor, and that Michael donor here is going to be a conjugated, the Michael donor is going to be a stabilized enolate, the Michael acceptor is going to be a conjugated carbonyl. So sodium hydroxide in this step is simply going to deprotonate one of these alpha hydrogens, forming a fairly stable enolate, being that it's on an alpha carbon that's alpha to 2 carbonyls. So two additional resonance structures, not just one, like a normal enolate. So, and in this case then, this is going to come and do conjugate addition, Michael addition, attacking the beta carbon instead of the carbonyl carbon. So we've added 1, 2, 3, 4 carbons, 1, 2, 3, 4 carbons, and after the tautomerization, it's originally going to form an enol, but after tautomerization, it goes back to being a ketone. So we've now got 3 carbonyls in this molecule, and we are simply going to add NaOH and heat and do an intramolecular aldol now, step 2. And the idea in an intramolecular aldol, if you recall, 5 and 6-membered rings forming is more likely. So you might be like, well, we could form an enolate right here maybe, and that would be 1, 2, 3, 4, or 1, 2, 3, 4, and it's going to form a form ring either way. That's not going to be likely, so we won't even consider that. But out here, or either one of these technically, we can form a 1, 2, 3, 4, 5, 6-membered ring if we attack this carbonyl, or same diff on the other side, a 6-membered ring if we attack that carbonyl. So I'll look at it, envision attacking that carbonyl right there. So, and I'll number this where I've formed new bonds here. So 1, or a new ring anyways, 1, 2, 3, 4, 5, 6. So we're going to form a brand new 6-membered ring here. So, and I'm going to make this carbon number 1. So, and number around 2, 3, 4, 5, 6. We can see that 5 is still going to have a carbonyl. So carbon 1 here is going to now have a bond, and that's going to, O is going to get protonated and be an OH, so it kind of skips, not going to go through the full mechanism here. And then carbon 2 is still going to have this acyl group, acetyl group I should say, attached as well. And that's what this would look like, but we're heating it, so we're not just stopping at the aldol addition reaction, we're going to go all the way through the aldol condensation reaction here. So, and in this case, cool, and there's your aldol condensation product. So right between our alpha carbon and where the OH is, giving us this lovely molecule. Now technically, if you look here, we formed the double bond right here because it was between the alpha and the beta, but technically on the other side there's an alpha and a beta there, and so the double bond might actually form there as well. Not something we would have considered in the past, but in this molecule, something we definitely have to account for. And so you're actually going to get 2 different products here possible. Cool. And that would be the products of this Robinson annulation.